Hello everyone, I'm Christopher Saldana. I'm an Associate Professor of Mechanical Engineering here at Georgia Tech. I'm standing in front of the IDEA Laboratory, which is one of our primary spaces that we use for facilitating ME 2110 Creative Decisions in Design, which is our introductory mechanical design course. I'll be talking about the laboratory as well as the classroom associated with this laboratory here in a couple minutes. Before we get in there, I'll show you here our scheduling kiosk. So what we ask students to do is actually reserve space within this laboratory, especially under the current environment. So what students can do is they can go in here and schedule time on our 3D printers, our laser cutter, as well as the workstations, the assembly workstations that are available, or PCs. They can do that right here at this kiosk. So it's called the Shared User Management System. They can actually go in and sign on online and reserve that time, and then access this and log in here at this kiosk, or using any one of these QR codes. So as we get into the classroom, you see here at the front we have a variety of signage that indicate what we expect of the students in terms of attire. You have to wear closed-toed shoes. You have to have specific kinds of clothing on, face coverings, and of course a variety of other health check items coming in here. So as we get into the IDEA Laboratory classroom, this is the space that we use for engaging with the students in what are called studio sections. So this primary class takes in about 200 to 300 students every semester, fall, spring, and summer. And typically it's broken up into a main lecture where the lead course coordinator, which is myself this semester, will introduce design tools to the students, structure design processes, technical communication principles, and things like that. And then what the students will do in groups of about 20 to 24 students, get into these individual studio sections and work directly with a faculty member as well as with a teaching assistant on exercising those design tools on conceptual problems, real-world problems. And this is an example of a manifestation of one of those projects. This is our final project. So we have our end of the semester robotic competition, happens around week 12 to week 14 of the semester. They can use the resources within this laboratory to produce, the fabrication resources to produce these systems, and then they will actually end up competing in that event. So this is the particular design that won actually in fall of 2019. So this space is our classroom space. So here, generally, this is where we're instructing with students and working with them on these design problems. Right now, we have it set up in a laboratory mode where we're using it for fabrication. You see here at the front, we have safety glasses available to the students. So typically, students will be just picking up safety glasses and using them. This semester, we provided safety glasses free to all students. But if they've forgotten it, they could pick it up here, and then they can use it through the space, and then we'll sanitize them, and I'll show you that here later on. At the front, we have sterilizer, cleaning supplies. We're also giving face shields to all of our students. There's face masks available here. And one thing that we're requiring under COVID is actually temperature checks. So we have a temperature gun here that we use to check forehead temperatures, and that's done by a teaching assistant. As you come across here, you'll see our primary TV that we use for instruction as well as for presentations, and our lectern here at the front of the classroom. And this is typically where the instructor will be engaging with these 20 to 24 students on looking at a structured design problem, and as well as using this for lectures, and also for students to come and give presentations. So students will give presentations to their group of 20 to 24 students, as well as in front of the instructor to get practice on technical communication. Right now we have it set up for a teaching assistant station. So the teaching assistant is going to be here monitoring the space. We have two available at any given time. This is outside of classroom hours. So they come here. We have these barriers that are spread out throughout the space, not only here at these teaching assistant stations, but also on work tables and around common pieces of equipment where we're providing that extra layer of protection for our students. As you come back through here, I'll show you some of our computer workstations. So we have a bank of 8 computers here. Right now we're set up for 4 with COVID. However, the students can use this space. It's reservable inside of our shared user management system, and they can actually sign up for time on these computers. They're loaded with our software that are used for fabrication. That's for 3D printing, for laser cutting, and for CNC milling, but also for mechatronics programming. So each of the teams is given a kit that contains these variety of sensors and actuators for their robotic systems. We'll have things like pneumatics, motors, solenoids in terms of power sources for their systems, but also sensing elements, things like potentiometers, encoders, push button switches, roller switches, IR sensors. Those are all going to be integrated by those teams onto those robotic systems to produce something that actually accomplishes a physical task. We also have given students a microcontroller, in fact 2 microcontrollers per team. This semester we're trying the Arduino Uno. In past semesters we've used the National Instruments MyRio as well as the Raspberry Pi as platforms for that. So students can use any one of these workstations to troubleshoot what's going on with their circuits. They can engage with a teaching assistant if they have questions on programming or algorithm design for their control systems and things along those lines. Throughout the space we have these work tables where students can obviously use these spaces for assembly. We have sterilization or sanitization equipment, sprays and wipes that are available as well. So this classroom is generally used for instruction. We have it set up for fabrication right now. You see here a track that is kind of providing guidance for what the flow is through this space. We want a one-directional flow through the space so we don't have people backing up on each other. Right now we're entering the Idea Laboratory fabrication space. This is the primary laboratory where we actually house a lot of our fabrication equipment, things like the 3D printers, the CNC machines, and the laser cutter. And this is where students can come in and use those facilities. So one thing to note as we get into this space and you look at the walls around this space, we have signage spread throughout on reinforcing what are our safety principles, what are the operational guidelines of using this facility, and what is expected of being a good steward of the shop. We actually build stewardship into our syllabus, so if students are misusing the space or not being a good steward of the overall activity here, that will affect their grades. So we want to make sure that we train students to be good professional stewards in practice. So typically in a given semester we might have at any one time 100 to 120 people in here actually working on their robotic systems. Under COVID, we are reducing that through our scheduling activity, but we'll see a variety of resources that students can access within that constraint. So right here we have our power tool station. This are a range of power drills, hammer drills, jigsaws, and the variety of tools that are used for that to access for fabrication activities. Right now this is open checkout, so students can come in and grab it and put it back as they wish. In heavier weeks we might have this monitored by TA, but we don't have that situation this semester under the current guidance. So we have also our electronics assembly station. So this is where they can repair their circuits, wiring. So these are soldering workstations and fume hood that students can access for troubleshooting their problems that they're having on their circuits. One thing I'll point out here is our red books. So we have our training manual here. The training manual is basically a formalized document that we use to train our students on all pieces of equipment as well as safety in this laboratory. Because we are training such a large group of users and we have a variety of trainers, we want to make sure that we have a formal lesson plan and document for reference. So this is posted online on our course website at 2110.me.gatech.edu. And there the students can actually check and see if they have any questions about training either before the training activity, during the training activity, or after the training activity. And also the TAs have a lesson plan to follow so that they make sure that they hit on all the points that we want them to hit on in terms of safety and operation. So you can actually consult the website if you want to see that yourself. We also have here our emergency document. So this is our red book. This has guidance on what are some of the procedures in case of an emergency situation, in case a student gets hurt, in case a staff member gets hurt. What are the reporting procedures that are required, and how do we handle the space? So these are available here for reference in case of any emergency. And we have both of these items also at the front of our classroom space. As we come through here, we have a teaching assistant station. Again, it's a monitored space so that we want to make sure that the TAs can monitor what's going on and identify any issues. Our primary equipment are video monitored so that the TAs can monitor that from their TA stations. We have here our manual tool checkout. So these are your hex keys, your screwdrivers, your pliers, staple guns, tape measures, clamps, hammers. These are things that students can access as they wish and bring to their workstations. What you see in the back here is our robotic storage. So this is where students can leave their intermediate systems week to week, and that way they don't all have to be in the space at one time. They can, come in, work a little bit, someone else can come in and work a little bit, and they have a common place to leave that. So we basically provide a garage for each of their robotic systems. And you're actually ready to see the start of the robotic competition this semester, as we're in about week 6 or week 7 of the semester. The students are already starting to use this for their chassis, for their robots. On the right side of where I'm standing, we have our 3D printer bank. These are a bank of 5 Ultimaker 2 Pluses. So this is fused deposition modeling. We provide filament free to the students, so if they want to print something, they go to use the software, generate G-code, bring the model here, and then actually start producing a component using 3D printing. So we give a budget of time for the students, depending on how much time available we have in the week. And then again, here are cameras monitoring the build activity. We train students on operation of the equipment, but also on safe use. So with the 3D printers, the primary hazard is, as you're removing items with the build plate with a putty knife, you can actually slip and cut yourself. So we provide cut-resistant gloves and guidance on how to remove items from the build plate safely, as well as nitrile gloves for reducing transmission opportunities. What the students are using this for is to produce components like this. So this is an example of a structural component for mounting one of the DC motors on the robotic system. So they'll print this and then use this to mount any one of their items. As we come around here, we'll see some of the other pieces of equipment that we have available. This is a manual engine lathe equipped with a digital readout. It's a great piece of tooling for actually producing components to a specification. When we train students on this piece of equipment, we essentially build into the training assignment not only how much material they use, are they scrapping out material, but also what is the final dimensions of the part, so that we're checking not only on can they produce it, but can they produce it effectively and within a certain budget. So they have that available for them. We also have a milling machine that's a 3-axis milling machine. Very similar kind of principles. You're using a precision fabrication process to produce a component to a tolerant specification. And both of these are used kind of hand in hand depending on the kinds of parts that the students are targeting. You see on the back wall some more signage, eye protection requirement, materials that are allowed to be used in this shop, as well as emergency contact information, and then of course some more general pieces of information. As we come across here, you'll see more work tables with these barriers laid out on them that students can reserve within the scheduling resource. And as we come over here, we're going to see the woodworking activity that also is available. Because wood is a very common primary fabrication material for prototyping, we have these wood fabrication resources, so a bandsaw, drill press, and miter saw. And students can use this, and we also provide scrap wood for the students to use for prototyping. And one thing to point out is that throughout this space we have vacuum cleaners, and that's an important part, making sure that students are cleaning up after themselves, especially in the woodworking activity where you generate sawdust and you have to keep that down in order to keep a safe environment. We ask the students to make sure that they clean up after themselves using the vacuum cleaners. As we come across here, we'll see our laser cutter. So the laser cutter is used for more rapid fabrication, more hands-off fabrication. So the students will produce a component. It's typically a 2D design that's out of a sheet of wood or plastic or something like that, acrylic, and then they'll produce it on this system here. So we train them not only on safe operation, what are the materials that they're allowed to use here, as well as providing quick reference guides and the training guides. So if you want to read about the training for this particular piece of equipment, you can consult the training manual that's posted at the front of the laboratory and online. But also safety. So we have fire blankets and fire extinguishers that we could use, and we train the students on what are the mitigation plans in case something goes wrong on this piece of equipment. We also have a large format TV at the front of the equipment that we use for display. So oftentimes in this piece of equipment you might have someone helping you troubleshoot, or you might have the TA come over. So the TV is meant to provide a space where you can actually not have to crowd around the same small monitor. And then of course we have our camera here that the TA is using to monitor the build process to make sure nothing's going wrong. As you come back through here, what we're going to see is our other computer-controlled manufacturing equipment. So this is our CNC Milling Machine, which is a 3-axis computer-controlled machine that we use for precision milling. So here, what we're doing in lecture and in the classroom is we're training the students on the software for this machine, as well as giving them an opportunity to learn about computer-aided manufacturing. And then we go into the laboratory in this space and actually teach the students not only how to set up this machine and how to use it safely, but also how to run the controller, which is a Siemens 828D controller, which actually has a lot of familiarity to the 840D, which is used a lot more in practice. So we train the students on that. To my right here, we have more of our safety equipment for the facility, our first aid kits, our fire extinguishers, and our eye wash stations. These are all marked on a map for the students in case they need to quickly reference where these items are. Again, we have first aid kits spread out throughout the facility, as well as fire extinguishers. The eye wash station is there also in case of emergencies. As we come out through this space, Another important thing for the students is as they're done using any of these resources, especially under this semester where we are requiring scheduling of this activity, they have to sign out of these resources. So at the front of every machine, we have a QR code that they can scan with their phones that signs them out of the laboratories as they're leaving it. But as they're leaving the laboratory and getting back into this single direction track, we also have QR codes that are at the front of the laboratory so they can come up here. If they forgot to sign out of a 3D printer, they can take their camera, point it at the QR code, and that will sign them out of the facility. So as we're running out, what we see is we see more signage. And if they have borrowed a pair of safety glasses from the common bin at the front of the laboratory, they can put them here in the dirty bin. And then we have a UV cabinet that the TAs or professional staff will actually run themselves. So once that bin gets full, we'll load this full of safety glasses, we'll sterilize those safety glasses, and then they'll be ready for new students to come into the laboratory. And then at the front, we have more of these sterilization kinds of items. At the front of this laboratory, or the exit as we have it configured currently, we also have our Stratasys F170s. These are fused deposition modeling machines as well. However, they're a lot more complicated. They're set up for batch mode for producing larger parts or a large number of parts. So these are run by either our TAs or our professional staff. Students will submit jobs to our website, and then we will run them here. Whereas in the Ultimaker 2 Pluses that I showed you about halfway through the video, those are actually able to be used by the students as they wish. So this is the exit to our laboratory. As we go through the doors here, you'll enter the Web for Design Commons, which consists of the other makerspaces and facilities here inside of mechanical engineering. But this is the primary fabrication space that we have available for ME 2110 Creative Decisions in Design. And if you had any questions or you wanted to look and find more information about this class, you can go to the website 2110.me.gatech.edu and learn more about it there. I'm Chris Saldana, and thank you very much for watching this video.